But everything that you've done so far, it's already been in standard form. So like this is familiar to you. And that's a quadratic in standard form. And the reason that's familiar to you is you know exactly how to graph that. You know where the shifts are. You know you're going over to 5.
Are you recording?
I am, but thank you. Thank you. You're going to have to do that like 12 times today. So you know where your shifts are, and that tells you where your vertex is. So I know that my vertex, so we're going to take this to the next level. We know how to shift that, which means we're over here at positive 5. That's the x-coordinate of my vertex. And I'm up 3 places. Well, that's the y-coordinate of my vertex. So it's sort of same thing you've been doing, just different way to write your answer. You're not going to have to graph it right now, but you are going to have to be able to look at that equation and tell me where the vertex is. Because the vertex is where you're going to find your answer as far as what's the maximum, what's the minimum, things like that. Because in a parabola, you will always have either the lowest point on that graph, or if it's upside down, you would have a highest point. And that's always your vertex. So if it's given to us in that format, we don't have to do any work. We can just look at it and tell what the vertex is. So if I give you like x plus 2 squared minus 1, it's a quadratic that makes a parabola. What's the vertex of that? Yep. Negative 2, negative 1, right? Yep. Because you would shift that over to negative 2 and down 1. So here's your vertex right there. Oh, my God. There you go. All right. When both things are represented, it's a little bit easier. It might be a little bit harder. Stop it. Oh. You can't see my Facebook notifications, can't you? No. That's weird. This one's a little bit harder. It's a little less obvious. Any guesses on that vertex? Think about what the graph would look like. Yeah? Well, and then what? -5. 0, -5. Good. All right. You don't shift over at all. So it's 0, but it is down 5. So that's the vertex 0, -5. All right, good. And then last one. So if you just had that, what's that vertex?
-1, 0.
Yeah, good. You would shift over to -1, and then there is no up or down. There's nothing added or subtracted. So that would be -1, 0 for your vertex. Okay. Oh, sorry, we got a couple more to do. At least it's nice and colorful. Well, the colors don't come out in here. You can't even appreciate this rainbow of joy I'm bringing you. Negative x. All right, this gets a little bit trickier. Yeah. +1, all right. That's a little bit trickier. Think about how you would graph it. So it wouldn't be 5. It'd be -5, 1. Yeah. Because this one, remember that negative inside, it affects your shift. So normally, without that negative, you would go to +5, but that negative reverses your shift. Or if you think about, if you solved this thing, what do you plug in for x that would make it 0? If I plug in +5, I get -5 minus 5, which is -10. So it's got to be -5, 1. So be careful with those negatives. They will affect your shift. They'll affect your x coordinate. So remember, do the opposite rule. All right, let's scoot everybody. And then this one, no, negative x plus 2 squared minus 5. What about negative on the outside? Think about what that graph would look like. And then tell me the vertex. Or if you need to, look at one of them on your test you just got back that had a negative out front.
-2, -5.
It'd be -2. -5, yep. So that negative out front does not affect your shift. All that did is turn your parabola upside down. But you still would have, if you look at your test, there was one like that. Let's see. Which one was it? So number 3. Number 3, if you got 3 correct, it's just like this. So that negative, all it did to you is tell you to turn that parabola upside down. But you did shift, you always go the opposite direction here. So you would go to -2 here on your test. I think you had to go to +4. And then you do go down 5. So all that negative does, not do, that thing makes it upside down. That thing done did it, but that's still your vertex. So this vertex would be the smallest, the lowest point on that graph. This one is the highest point on that graph because it's upside down. So this is actually the maximum point, and that would be the minimum. That's how we're going to be using these numbers. Okay, but that's boring. I mean, it's all boring, but that's more boring than this. Well, that really sold it to you, didn't it? I feel certain. So what if your equation looks like this? Okay, now you can't eyeball it anymore. You can't just look at it and tell me what the graph is going to look like. You can't just look at it and tell me what the vertex is. So you're going to have to do some work, and that's where we're staying today. How to get that into this format with something added or subtracted off to the side. You're going to make it into that. What's that?
I was going to say 4x out.
Do the quadratic formula, is that what you're saying? What did you say?
Yeah.
Yeah. We don't want to do that here because that gives us the solution. It tells you where we get zeros. But we're going to do completing the square, which you learned in Algebra 1 also. So it's very similar. So we want this right here, we want to convert it into that format. It's a series of steps. None of the steps are difficult. It's things like divide by a number, subtract a number, add a number. But there are like 6 of them that you do have to memorize. All right, so here's the process. It's happening. This is happening. I don't think it just gave me a big eraser, even though I said, give me the big eraser. Hopefully this is semi-familiar to you, but if it's not, that's okay. First thing we need to do is we need to create a perfect square. And this little pesky thing right here is a problem. That little 1 tacked onto the edge is not a perfect square. It's not like 1 times 1 does not give us 4 when we add. So that's a problem. So get rid of that number. That's step 1. If you have a constant, it's called a constant, a number without an x. Move your constant over. Step 1. When you move something in algebra, you always do the opposite operation. So I have y plus 1 over here. All right, that's my step 1. Got that pesky thing out of the way. Now you're going to create a perfect square. So it's like doing FOIL backwards. Take this middle term right here. This middle term. This is an off to the side thing. So I'm going to make a little box off to the side. Whatever that is, we have positive 4. Cut it in half. That means divide by 2. Okay? And then whatever you got when you divide by 2, you're going to square it. Multiply it by itself. 2 times 2 gives us 4. We end up with 4 back. That's just a coincidence. It won't always be that way. It just is for that. So I did those 2 steps off to the side. What I'm setting up is a perfect square trinomial. And you'll see in a minute. But it's 2 steps. It's 2 steps. Let's make it sassy for the video. An arrow feels sassy. Step 1 is take that middle term, whatever it is. In this case, it was a positive 4. That's what we put right there. Divide it by 2. You always divide it by 2. Cut it in half. And that, you get 2. And now you take that answer and you square it. 2 squared gives us 4. 4 tells you what to add here. So we're setting up a perfect situation. We have a perfect trinomial if we have the number 4 there. And you'll see why momentarily. So for your notes, I would recommend you letting yourself know that that number went right there. That's what you're adding. But I did not finish this step. I have an equal sign right there. So, and I added 4 to the right side of that equal sign, so I have to add 4 to the left side as well. In order for those to remain equal, I can't just increase this by 4 and not increase the other. Teachers, that's a concept you know. You're going to give the left side of the room some candy and the right side none? Good luck with that. 20 parents in your room by the end of the day. X squared plus 4x plus 4. So you've got your off to the side steps. That tells you what to add to the right side. Just make sure you also do that to the left side so that it's equal. And then 1 plus 4 is how I got that 5. I added these two together right here. That gave me 5. So far the steps are easy. It's just you already can see what the problem's going to be. Memorizing all these and being able to do them when your notes aren't there. But we're not there yet, so that's okay. All right, I'm going to factor this. This factors as a perfect square. But if I didn't know that, here's how it would factor initially. Factoring means figure out what was in the parentheses that you multiplied together to get x squared plus 4x plus 4. I know I had an x and an x. When you first learned how to do this, you hopefully learned some variation of what are all the ways I can multiply two numbers and get 4. So that's what I'm doing here. It's either 1 times 4 or it's 2 times 2. 2 and 2 is the right answer. Look, it looks like 2 and z. 2 and 2 is the right answer because you always test them by adding to see which one is going to give you 4. So you always look at that middle term. That's why it's 2 and 2. Okay, and then hopefully, if you notice in this example, we have the same parentheses twice. So we're going to write that as x plus 2 squared, because that's what it is. So I have y plus 5 over there on the left equals x plus 2 squared. It's starting to look in a format that we're used to. Almost there. One thing we got to do, we want y by itself. Move that 5 back over. So we're going to subtract both sides by 5. Don't try to subtract 2 and 5. That 2 is trapped inside parentheses. You can't subtract 5 from it. And you get y equals x plus 2 squared minus 5. Now we know what the vertex is. So now I know the vertex is negative 2, because I would shift that over to the left 2 spaces, and then down 5. Would that point be a minimum, meaning the smallest point on that graph, or a maximum, the highest point?
Minimum.
Why minimum?
It's low.
Because it's low, because this is a right side up parabola, right? I mean, it makes a U shape. I know that because there's no negative in front. And so the vertex would be down here as the lowest point. All right, that was good. Oh, good. Good choice. Good choice. Subtract 5. Remember, in algebra, when you move something, you have to do the opposite. So we got to subtract 5. That will cancel it out. Y equals x minus 3 squared minus 5. Oh, James Russell, you were right. You said 3 and I said negative 3. But it is 3. I was thinking what it factors as. It's a good thing you're here. Positive 3 is the x coordinate, because you always go the opposite of what's inside. Negative 5 is the y coordinate. All right. I'm going to give you 2. I'll let you work through them before it gets ugly.